This is the pre-lab video for the synthesis reaction of steel wool and oxygen. Now, if you have not done it already, pause this video and go into our Google Classroom and copy down the information that's provided for you for this lab, because there's going to be questions at the end of this and it'll be a lot easier to answer them if you have that information copied down. Overall, procedure-wise, this lab is pretty easy. You're going to take steel wool and you are going to get the mass of it before you burn it and after you burn it. And you're going to see if the mass goes up, and then we're going to figure out why. So when you're doing this for number 2, before you even start the lab, what you want to do right now is make a prediction. Do you think the mass is going to go up, go down, stay the same? Remember, this is an open system. All you're doing is heating steel wool over a Bunsen burner. So think about what's going on, make a prediction there. Right? You can't get a prediction wrong. The only way you can lose points is if you don't do a prediction. When you're doing this, you want to make observations. It tells you down a little farther to make some observations. I want them to be complete sentences. Do not use words like it or they. Right? If you're talking about the steel wool, say the steel wool was. Or if you're talking about the Bunsen burner, say the Bunsen burner was. Right, they could be simplistic, but I want them to be complete sentences, and I want them to contain descriptive words. You want to keep track of the mass before and after you heat it, and then we're going to get into the balanced equation. So for the things at the bottom, it will really help if you go to Google Classroom and copy the stuff down for those things at the bottom. It'll make it a lot easier for you. You do not need a whole lot in the way of equipment for this. You're going to have the evaporating dish. This is what's going to be on the balance, because you don't want to put something hot right on the balance. The steel wool generally is kind of like a fluffy stuff, so what you want to do is roll it into a ball. If it's already rolled into a ball, go through this step anyway, because you want to get any loose pieces broken off of there right away before you mass it. So once it's rolled into a ball, you put it into the evaporating dish. Make sure your balance is reading 0 at this point, and write down that mass. Once you have that, you're going to need tongs to hold this over the Bunsen burner. And you want to light your Bunsen burner. Remember, safety techniques, safety glasses on. If you have long hair, tie it back. Any baggy clothes or necklaces or anything like that, just be mindful of that. Make sure they're nowhere near the fire. Now, it's hard to see in the video, I think, but you don't want this steel wool to be all the way down right at the top of the Bunsen burner. That's not the hardest part of the flame. And you also don't want it all the way up. There's this inner blue cone there, a bright blue cone, and you want it right at the top of that. And when you're doing this, I think holding it in there for about 3 minutes should be okay. And when you're doing this, every once in a while you kind of want to turn it over, because you want to get that whole thing heated evenly. And you can see this steel wool starts to glow red or orange pretty quickly, so this is going to be really hot. If you drop it, do not try and pick it up with your fingers. Sometimes the first reaction is to try to pick something up right away, right? Avoid that urge. Now, once you have that in there for a couple minutes, you're going to put it back into the evaporating dish. So what I would do is let it cool for a little bit before you put it back in the evaporating dish. Now, I didn't leave mine in there for too long, so it came off of the tongs pretty easily. What happens when you leave them in there for like 3 minutes or something like that, sometimes they get stuck to the tongs. So what you have to use is either the scrupula or maybe like little tweezers, and over the evaporating dish you have to make sure you knock it in there and gently knock any pieces that might be stuck to the tongs into the evaporating dish, because you all want it in there. You want all that stuff to make it into the evaporating dish. Turn off the Bunsen burner. You can observe the mass, whether it stayed the same, went up, went down. And if remember to get information from the PowerPoint before you answer the questions at the end of this video. Overall, that's pretty much it. The steel wool should end up in the trash can when it's cool enough. Don't throw it in burning hot, because it will burn a hole in the plastic trash bag. But that's the general idea. This is the pre-lab video for the aluminum and copper 2 chloride reaction. It gives you the reaction right here, which you should be able to balance at this point. Gives you an idea of what type of equipment we'll need, and then there are some procedure questions. When you are doing this, we're really going to focus on 2 different types of data. There's quantitative data, that is data that involves numbers, and that's what's at the bottom of this page. So things like initial temperature, temperature after the copper 2 chloride was added to the water, the temperature after the aluminum was added. So numbers, that's quantitative. Then on the next page, it's asking you for qualitative data. These are observations that you can make with your senses, and this is the part that might take a little bit more thought on your part. So I'm asking for 3 observations before the aluminum was added and after the aluminum was added. Qualitative observations should not include any numbers, so I don't want to see anything about a temperature, saying 20 degrees Celsius or something like that. No numbers. Qualitative is what you observe with your senses. The observations should be complete sentences, and I'm fine with them being simplistic, but you must use descriptive words. Don't say it or they. If you're talking about the aluminum foil, say the aluminum foil. If you're talking about the copper 2 chloride, say the copper 2 chloride, or the copper 2 chloride in water solution, or the mixture after aluminum was added to the copper 2 chloride solution. Simple observations are fine, but use descriptive words, and then you should be able to answer these questions at the bottom. Procedure-wise, it's pretty straightforward. There's a good chance that I will have the copper 2 chloride solution or solid already massed out. It says about 1 gram, so if I have it massed out, just take it. If I don't, then you'll have to mass it out yourself, but I'll probably have that done. You will need a graduated cylinder because you're going to need 15 milliliters of water. You're going to pour that 15 milliliters of water into an empty test tube. Now, there are different test tube holders around the room. This one, I don't know if you can see that well, but the opening's really big, so I don't think it holds these test tubes very well because they could slide out very easily. So if I had one of those at my bench, what I would then use instead is just a smaller beaker, and that will hold it a little better. You will also need a stirring rod and a piece of aluminum foil. So once you have the water in the test tube, you are going to use a thermometer to record the temperature. Now the thermometer goes up by 1 degree Celsius. So remember that whole you estimate one place past what you know. If the thermometer's resolution is 1 degree Celsius, then you measure to 0.1. You should have one number after the decimal point. So even if the thermometer, the red alcohol, even if that lands exactly on 30, you write it down as 30.0 degrees Celsius. All right, these always go to 1 decimal point. So that is going to be the initial temperature of the water, just the water in the test tube. And now what you're going to do is take that copper 2 chloride, and these weigh boats work really well. You could just bend it, and then you could just dump it into the test tube like that. All right, get that in there. And now you're going to use the glass stirring rod to dissolve the copper 2 chloride in the water. You want to get the temperature again of that and write that down in your packet at the bottom. Now when you're doing this, remember you have to make observations as you go. Don't leave observations all the way till the end, like when you're done the experiment and you're cleaning up and you're trying to remember back to what you did. When you are starting this experiment, you should be making these observations as you go. All right, so this is still before we add the aluminum foil. Now there's going to be aluminum foil up front, just different sizes, different amounts. And when you're working with this, you want it as loosely crumpled as you can get it, but still being able to fit into the test tube. What you do not want to do is crumble this into a really, really tight ball. It's never going to be able to react fully like that. So you want it loosely crumpled enough to fit into here. And then if you have to, you could use the glass stirring rod to kind of prod it down into the solution and stir it a little bit. And then you want to put the thermometer in there and record the highest temperature reached. And then that's what you're going to record at the bottom here. Temperature after aluminum was added, that's the highest temperature that the reaction reached. Remember, make observations as you go. When you are done, you are going to have some undissolved solid in the test tube. Do not put this down the drain. I will have a filtration apparatus set up front to help with filtration. I will point that out at the beginning of the period, so make sure you pay attention to that, and then you can answer the questions at the bottom. That is the general idea for this lab. Overall, it's pretty easy. Practice making qualitative and quantitative observations.